Beautiful. Sanibonani. Makebalo. Today we are doing this revision of this paper, which is a Gauteng paper that was written in September 2024. Let's get into it here. We're having the graph of UGA prime x, meaning the derivative, which is this one, and we're having a straight line graph, which is this one. They've drawn us here, and the sketch or the graph of g prime of x is a derivative of the cubic graph, which is very important. Now you need to understand in terms of what does the derivative of a cubic graph give us. That is very, very important, because in order for us to interpret this, we need to understand in terms of the cubic graph and the derivative of it. And the graph of H and G is a common y-intercept at E, meaning here we have the y-intercepts they've told us, and we have a point of C, which is this one, a point of D, which is this one, and then they tell us that those are the x-intercepts of G of prime. And point A is x-intercept of H, which is this one, and the point of B is a turning point of G of prime. Then this is, I hope you can see also, this dotted line is telling us that this A and this B, they share what? The x coordinate. And the line AB is parallel to the y axis. Now this line is parallel to the y axis. Now let's get into the questions. Now the questions, they're saying write down the coordinates of E. Remember, they told us that the coordinates of E is what? Is the y-intercept. Now according to this straight line graph, I know this is going to be my y-intercept. Now I know my x here is 0, and when the x is 0 and then my y is -4, it's also 1 mark, so they just want the coordinate. So the coordinate is going to be 0 maps to -4. So this is the coordinate of E. Now 9.1.2, they are saying let's determine the equation of g of prime, which is the derivative in the form of this. Now we know here, according to what we have in this graph, we're having this point and this point, which is my x-intercept, and I'm having this y-intercept as a point in a graph. So if I'm having the x-intercept, this is the one form of that we're going to use in order for us to find an equation. So it's y into a into x minus x1, and then x into x2. Now what is very important here is that x2 or x1 is this x here, and then x2 is this x that I have here. And now this one is a point that is in the graph. In this case, the point that I have in this graph is this one here, which is 0 into -4, which is the one that I'm going to substitute in this y as -4, and also this x and this x, I'm going to substitute the 0. Now, that is a very important part that we also need to understand. Now, let's substitute. Now, this is 0 equals to my a, oh, it's not 0, man, sorry, it's -4. This is -4, sorry about that. This is -4, and then a, now that's where my 0 is. Now this negative and this negative gonna give me +2, and then 0, and then this -6, and then this is -4. Now if I times this, it's gonna give me -12 into a. -12 divided by -12, and then my a is going to be +1/3. Now, after here, remember I'm looking, so it's going to be y is equal to, substitute this over 3 into x plus 2 into x minus 6. Now y into over 3. Now open the bracket here, is going to give me x squared minus 6x plus 2x and minus 12. Then from here, it's going to be 1/3 into, this is x squared, and then -6 plus 2, it's going to give me -4x and minus 12. And then from here, times in here, it's going to be 1/3. x squared, and then this and this is just negative 4 over 3x, and then this and this is going to be, it has to give me this negative 4 here, which it is negative 4. So this is now the equation of g in the form of y into x squared plus bx plus c. Now going to write down the x coordinate of the turning point of g. Remember, g is the cubic function. Now what is very important, we need to understand now, these are the x intercept of this parabola. Now the x intercepts of the parabola are the x of a turning point. Now this is very important. This x and this x, these y x intercepts are the x of the turning point. So the x of a turning point here is going to be x is equals to negative 2 and another x of a turning point, because the x of the turning point are the x-intercepts in this graph. So another x is going to be x into positive 6. That is very important concepts that we need to understand. And another one here, which is this question that is following, they are telling us that let's write down the x-coordinate of the point of inflection of G. Now again, the point of inflection of G is the turning point of this graph. Now the point of inflection, remember the point of inflection is a second derivative, which is, in this case, is a turning point of a parabola, which is that turning point of a parabola is an inflection point in a cubic graph. Now what is an x of this turning point here? Now how do you find the x of a turning point? Is x into minus b all over 2a, and then which is negative into, in this case, is negative 4 over 3, and then all over 2, and then my a is 1 over 3. Now getting this one here, we are going to get a positive 2. Now this is the x coordinate of the inflection graph. Now again, if you didn't see this one here, remember these two, they are sharing the same x, so we can take we know that here my y is 0. So if my y is 0, according to this graph, is going to be 0 is equals to 2x minus 4. This on the other side, it's 4 is equals to 2x. Then divide by 2, we divide by 2, and then my x here is what is 2. So this and this, both of them, they give me the same answer according to this graph, meaning in this graph also they do share the same x coordinate. Now explain why G, which is G, now remember G is the cubic graph, has a local maximum at x is equals to negative 2. Now if I can draw a graph, or if I can draw just a rough graph in terms of what was, if I can just put it somewhere there, because I'm trying to show you in terms of understanding what is going on in this specific question and the explanation of it. Because remember, this graph has to increase, because now if it increasing, this also graph is increasing, so the derivative of G is increasing. So our cubic graph needs to start by increasing and then going down. So here, if I can just remember, can put this somewhere here. This is just a rough graph. So also turning point here, guys, it's just a rough graph here. Now understanding, remember, remember the x intercept of this G prime, those are the x of a turning point, which is very, very important. Now this is my rough graph of the original graph of G, because this is what is G prime. I hope you can see now that my graph is what is positive. So graph of G is a positive graph, which is also what is happening here. We can see that the G prime of x is also what is positive. Positive, sorry about that. Which is therefore and y x of negative 2 is the maximum or the local maximum. You can also draw the sketch of a graph in terms of doing the explanation of 9.1.5. I hope we are understanding everything here. Thank you so much, guys. Omakebalo.